Today what we're going to try and do is quickly talk about the basic rules of exponents. So let's go and start with an example of x to the fifth. We know that x is the base and 5 is the exponent. And so we look and so we say that x times x times x times x times x is equal to x to the fifth. An exponent means multiplication. And so what we can say is that an exponent tells you how many times you multiply the base by itself. And don't get this confused with addition. If the 5 was in front of the x, then it would be x plus x plus x plus x plus x. An exponent means that you are multiplying. So to reiterate, an exponent tells you how many times you multiply the base by itself. So let's take a look at an example. Let's say we had 7 to the third power. This is saying 7 times 7 times 7. And so when we multiply 7 by 7, we get 49. And then 49 times 7, 9 times 7 is 63, so we carry the 6. And 7 times 4 is 28, plus 6 is 343. So 7 cubed is 343. So let's take a look at one more example with just variables. Y n to the fourth, that 4 only applies to the n. So you get y equals n times n times n times n. Alright, so let's take a look. Let's take a look at an example of division where you have the same base and you have exponents. So when you divide, the quick way to do it is to write your base and then it is the top exponent subtracting from the bottom one. So x to the 5 minus 2, so x to the third power is your solution. If you want to write it out the long way, x to the fifth is x times x times x times x times x divided by x times x. So then you can cancel out common factors that you have. So you're left with 3 x's on the top, and so we have x cubed, which is exactly the same. And let's take a look at yet another example here with some numbers and letters. So here we have 8xy to the third divided by 6x squared y squared. So let's go ahead and just write this out into its prime factorization. So we have 2 times 2 times 2 times x times y times y times y divided by 2 times 3 times x times x times y times y. And then we can come through and just cancel out the common factors. Okay, and then we can write our solution, which is 2 times 2 times y divided by 3 times x. And then let's go ahead and just simplify that down and say it's 4y divided by 3x. And that's our solution. So now let's take a look at multiplication. That was division. We subtract our exponents. So with multiplication, let's take this example, x to the 7th times x to the 3rd. We're going to add our exponents. So you have x to the 7 plus 3, which is x to the 10th power. Again, we could write this out the long way, and so we could say it's x times 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 x. Whew. That's the long way of doing it, and you just count them all up and you get x to the 10th power. Again, it says the same thing. So let's say we have a negative exponent in there. So let's say we have y to the 7th power times y to the negative 5th power. And so we add our exponents. So we have y to the 7 plus negative 5. And 7 plus negative 5 is 2. So we have y to the 2nd power. So from here, let's take a look at our positive exponents. We'll take a look at our exponents when they are 0. because these are different. And then we'll take a look at negative exponents. Again, these are different than our positive exponents and our zero exponents. So let's go ahead and start with our positive exponents. So let's say that we have 5 to the third power. So again, that's saying 5 times 5 times 5, which we know 5 times 5 is 25, times 5 is 125. When it comes to 0 as our exponent, so let's say we have 5 to the 0, any number to the 0 power is 1. And I'll post another video that kind of gives a little bit of an explanation from that. With negative exponents, if we have 5 to the negative third, the negative actually shows that our 5 to the third is on the bottom of a fraction. It doesn't determine whether our answer is positive or negative. So it comes out to be 1 over 125. So let's take a look at a few examples here. We're going to start out with x squared times y to the negative third. So we know that any negative exponent goes to the bottom of a fraction. So we have x squared remains on the top, divided by y to the third power. And so we can't reduce that down at all, so that's our solution. Another example we can take a look at would be x to the fifth divided by x to the negative third power. So now remember, when we divide, we subtract our exponents. So we say x to the fifth minus a negative 3. And remember, minus a negative says plus a positive. So 5 plus a positive 3 is 8, so we have x to the 8th. One other way to look at this is if you have a negative exponent on the bottom, you can move it to the top and your exponent becomes positive. So you move that whole thing. And then you have x to the fifth times x to the third, which becomes x to the 8th. So that's two different ways you can look at that same problem there. So this concludes our set on exponents.